So in my various gunsight videos on this channel, I show many of the gunsights in operation. If you have gunsights that you're interested in operating and just need some help to do so, this is the video for you. In it, I'll tell you about the bulbs used in the sights and show you some tips on how to power up a gunsight. I'll even go over how to fully power up a gyro sight for operation. Let's start with the light bulb, as it is at the heart of a reflector gun sight. No light, no sight. In the various videos I have on this channel covering gun sights in detail, I show specifically which bulb is used with each sight. I'm not going to go over that again here, but you may need to check out the other videos if you aren't sure which bulb is needed. This one here is the GE Mazda 844, by far the most common gun sight light bulb. The name Mazda may be a little confusing, but it has nothing to do with the Japanese automaker Mazda. Rather, Mazda was a product line brand name the General Electric used prior to World War II, named after the Zoroastrian god Ahura Mazda, whose name translates to light. Now, gunsight bulbs like these haven't been manufactured in the last 70 years, so finding them now is increasingly difficult. You can sometimes find them on eBay or by contacting a collector who has them. Fortunately, most gun sights use bulbs based on automotive bulbs, so finding substitutes shouldn't be hard if you know what to look for. So let's go into the basics of the light bulbs. There are several important attributes of light bulbs you need to be familiar with. Let's start with the base, that is, the metal bottom part of the bulb. There are two types of bulb bases: screw-in, which you're familiar with in household light bulbs, and bayonet style with locking lugs. You may recognize these types of bulbs from your car. Nearly all gunsight bulbs are bayonet style. Next is the base size in millimeters. The 15 millimeter base is used on the 844 and is fortunately very common on cars even today. Next is the type of contact. Almost every light bulb you're used to, whether in the home or the car, has a single contact. But most gunsight bulbs have dual contacts. Why? Because most bulbs are dual filament. This means there are actually two light bulbs in one. If one filament burns out, you can just switch to the other without changing the bulb. This redundancy is obviously necessary in a combat situation. Because light bulbs today are so much more reliable than they were 80 years ago, dual filament bulbs are nearly extinct. However, dual contact bulbs are not. By switching up your wiring, you can use a dual contact bulb in place of a dual filament bulb. So let's put it together. The Mazda 844 has a bayonet style 15 millimeter base with dual contacts. So look for a bulb with a BA15D base. The next several attributes we're going to look at are often printed on the bulb base. The first and most important is the voltage. Most U.S. military aircraft of World War II have a 24-volt DC electrical system. A few of the earlier ones had 12-volt systems, such as the Dauntless prior to the SBD-4 model. A 24-volt electrical system has a generator that generates 28 volts of power to create the positive power flow needed to charge the 24-volt battery and run accessories, such as the gun sight, that run on 22 to 24 volts. So a 24-volt gun sight bulb will often be marked as 28 volts, although it'll typically be used in the 22 to 24 volt range. Similarly, a 12-volt bulb would run on a 14-volt electrical system, so you'll sometimes see bulbs labeled 12 to 16 volts. Also, these voltages are for full power. To dim the bulbs, such as in dawn or dusk operations, you'd reduce the voltage. An important warning: never apply more voltage than the bulb is marked for. Applying 24 volts to a 12-volt bulb will make a bright flash and a burnt-out bulb. Next is candle power, which really isn't important, it just tells you how bright the bulb is. The Mazda 844 is marked with 21 CP, twice, as each filament produces 21 candle power. A quick side note: there's an interesting bulb you can substitute for the 844, and that is the Mazda 846 bulb. It's identical to the 844 with one exception. The second filament is only 6 candle power versus the other filament's standard 21 candle power, so you can effectively dim the bulb just by switching the filament. Next up is wattage. This tells you how bright the bulb will be by how much power it consumes. It's not important either, although you can divide the wattage by the voltage to find out how many amps of power the bulb draws. The next attribute of the bulb is its shape, that is, the shape of the glass portion. There are many different shapes and sizes. The Mazda 844 has a G9 shape, G for globe. Most automotive bulbs have an S8 shape, S for standard. But none of this is really important. All that matters is that it fits in the gun sight. For example, the Mazda 890 bulb has a unique shape designed specifically for the Mark 8 gun sight. But you can plug in another bulb without this shape and it'll still work, but likely not as brightly. The last attribute is the mask. Many gunsight bulbs have masks. That is, the bulb glass is painted silver everywhere except in the one place the light needs to come out of, which is frosted instead of painted. For example, the 844 has the light output on the side. The 836 has the light output on top. Again, you don't need to worry about the mask, as an unmasked bulb will still put out light, just in every direction. So now that you know the bulb attributes, you know what to look for in a substitute bulb. Will modern LED bulbs work in a gun sight? Yes, if the bulb fits and the voltage is correct, it should work. Be aware though of the color temperature, as LEDs produce a cold white light that doesn't match the warm incandescent glow that an original bulb would have, and this will make the color of your gun sight reticle whiter than it would have been. Now, moving on from bulbs, let's talk about power. To power your gun sight, you'll need a transformer to provide the 24-volt DC power that's needed. A simple wall wart style transformer would work, but I'd recommend a variable voltage transformer that goes up to at least 28 volts, such as this trusty old power supply here. A 3 amp power supply will work for most gun sights, but you might want 5 amps if you are running a gyro sight, and even 10 amps if you are running a computing sight or a bomb sight. Now let's power up some sights. Before hooking your transformer to the gun sight, test the bulb first. If you can't get the bulb to work outside of the sight, you definitely will not get it working inside the sight. First, set the voltage. For a 24-volt bulb, I'd recommend 16 to 22 volts, as you probably don't need maximum brightness. Next, connect the power to the bulb's contacts. The metal barrel of the bulb base is the negative, or common. The contacts on the bottom are both the positive and power each filament. But being DC, you can reverse the polarity with no problem. After testing the bulb, make sure you put it back in with the mask facing the right way, or the bulb will still light up correctly, but you won't know it. Next, let's look at the power connector. If there is only one pin on your connector, like on this N8A, just connect the positive to the pin and the negative to the plug body. If there are 2 pins, like on this N3B, connect the positive to either of the pins, as you only need one filament illuminated at a time, and again, the negative to the plug body. If there are 3 pins, like on this Mark 8, one is the negative and the other 2 are the positives for each filament. These plug configurations cover the majority of gun sights. But what about those sights with more than 3 pins? For those, you'll need either a wiring diagram, or you'll need to open the sight and trace the wires, or you can do trial and error and hope you don't burn something out. Let's look at a gyro sight, and I'll give you the wiring schematic you'll need here. I'm using a Mark 18 here, but the wiring is the same for a K14. First off, you'll need more than 2 test leads, so you'll need to construct a wiring harness or switch box. For the gyro sight, I used to use this switch box with a wall wart style transformer to demonstrate it. I now use my K14 desktop simulator. If you haven't seen it yet, check out my other videos for a demo of it because, well, it's really cool. Now, a switch box like this is not hard to build, but you'll probably have trouble finding the Canon plug connector, as they seem to be even more rare than the gun sight itself. So if you don't have the Canon plug, you can just use wires with pin contacts and plug them into the right place. So the negative or common goes into pin 1, the fixed reticle goes into pin 8, the gyro reticle goes into pin 9, and the gyro motor goes into pin 4. You'll need the full 24 volts for this and at least 5 amps of available power with all of the lights and motors running. And that's it. You can show the gyro sight in action. If you're trying to power up the B29 remote control turret sights, it's a little more tricky. The ring sight isn't too bad, as there are only 7 pins. But the pedestal sight has a 30-pin connector to cover the 4 cell SINs, the gyros, the range setting, and the 2 lights. Unfortunately, though, it seems that very few pedestal sites have this connector today. Most seem to have been cut off when the plane went to scrap. If you're fortunate enough to have one with a plug, let me know and I can provide some guidance on what pin goes where. So, there you have it. Everything you need to know to power up your gun sights and enjoy these fascinating technological marvels in their operating glory. I hope this was helpful. Thanks for watching and feel free to contact me with questions.